Again, we're going to graph the function g of x equals x to the 4 plus 2x cubed minus 6x squared minus 10x plus 2. We're going to do it on the calculator. Okay, so go to y equals, clear anything that's been there previously, and just type in what we have. So it's x to the power of, so this little hat symbol here gives you the power of 4 plus 2x cubed minus 6x squared minus 10x plus 2. Okay, and to see it, we do zoom 6. Okay, and we get a picture of what this looks like, and we may want to change the zoom a little bit because we're missing a little bit of this graph that looks important down here. So we can zoom out, and then press enter. And then we'll draw a box around the area that looks most important, which is sort of this area here. So zoom box, zoom 1, and move your cursor to a corner of the box that you're going to draw. So in a minute it's a sort of an imaginary box, but you're going to draw it now. Okay, so move across and down. We want to make sure we get all the turning points. Okay, so something like that. Okay, and that's a decent graph. Okay, and we're just going to sketch it now. Again, we won't bother putting on any scales because we just at this point want the shape of the graph. Okay, so that's what the graph looks like. Analyze the function for its zeros. Okay, so if we're going to look for zeros, we need to put in y, and we're going to make y2 equal to 0. Okay, that'll help us look for zeros. And then when we want to find the zeros, we'll go back here and mark them on here first. There's 1. Remember, the zeros are the places where the graph crosses the x-axis. 2. There's the third one, and here's the fourth one. So those are 4 zeros. Okay, those are the 4 zeros. And what do we do to find each of them? We do second calc, and then we press 5. Okay, and we move to whichever one we want. So I like to go from left to right, so I'll move to what I've represented here with a little green dot. Move over towards that direction, get as close as you can to it, press enter 3 times. 1, 2, 3. So there's your first one. X equals, so our zeros here. First one, x equals negative 2.77. I'd say correct 2 decimal places. Okay. Next we'll go for the red one, which is the next one over. So second calc 5. And we move over to the graph next crosses the x-axis, close to there. Hit enter 3 times, once, twice, 3 times. You get x equals negative 1.72. So x equals negative 1.72. Okay, we can look for the one in orange, which appears to be the origin, but let's just check. It may not necessarily be what it looks like. So second calc 5, and we move over to the graph, seems to cross the x-axis again, get as close as we can to it, somewhere around there, press enter once, twice, 3 times, you get x equals 0.18. So it wasn't the origin. Okay, it's 0.18, it wasn't the origin. And then the last one that I have, the purple one, x equals, it's over here. So second calc and 5, and move all the way over to that last one. Okay, that's pretty close there. Once, twice, 3 times. X equals 2.31. Okay, so those are the 4 zeros. Now, the maxima and minima. Okay, so there's a minimum, there's a minimum. So we can find each of these minima. Remember, for the minima, it's the y coordinate is what you're looking for. Okay. So for minima, it's second calc again. And for the minima, it's number 3. So just type 3. And let's get the one on the left first. So I'll move all the way over to the one on the left. Getting closer to it now. Okay, so I'm very close to it now. I want to go to the left of it a little bit. Press enter once. And now I want to come back to it and go to its right a little bit. Press enter once and skip the next one, just enter again. And you get y is equal to negative 3.099, so y equals negative 3.10. So remember, for maxima and minima, it's the y coordinate we're looking for. Right, we're going to get this other minima here. The one right down here. Let's find out what that is. So second calc 3, and go all the way over to that point. Right there. Oh, we've gone way too far. Okay. Alright, so we want to go to the left a little bit. Hit enter. Go back to the point and go to the right a little bit. Hit enter. Hit enter one more time. And you get y equals negative 14.70. y equals negative 14.70. So we're running up to 2 decimal places in this question, and that's what we've got so far. We also had to find the maximum. Okay, don't forget to do that one as well. So the maximum is here. Okay, so this is the maximum, and extrema relates to both minima and maxima. Okay, so we're going to look for the maximum, so it's going to be second calc and 4 for maximum. Okay, go as close to that maximum as you can get. Make sure you go to the left of it a little bit, 1, 2, 3, press enter, come back and go to the right of it a little bit, press enter, and enter again and ask you to guess, and you get y is equal to 5.61. Okay, y equals 5.61. So maximums, y values, zeros, x values. We're then asked to use the calculator to find g of 0.7. Okay, g of 0.7. g of 0.7. Okay, well, let's do that. What we can do in the calculator to find an actual value of a specific point is go to second calc, and number 1 will tell you the value. So just hit number 1 and type in 0.7. And you get g of 0.7 is equal to negative 7.01 corrected 2 decimal places. Okay. The domain and the range. Okay. The domain, remember, are what x values you can put into this equation and how far it stretches from left to right. Well, this equation would stretch all the way across your page from left to right if your page was tall enough. So the domain is all real numbers. Okay. The range, however, if you look at the graph, the range, this graph never goes below this second minima point. It never goes lower than that. And you might ask, well, how do you know? But you do know, and you can look at the trends and it'll tell you. So the range in this case, the y values that you do have on the graph never goes below negative 14.70. So in other words, the y has to be greater than or equal to negative 14.70. So the range is the set of y values such that y is greater than or equal to negative 14.70. Okay, thanks for watching.